Welcome back to this series of WICKERSON Studios and the Ghpython node geometry to the point and beyond. We're going to take a look at making a 2D array of points, which is probably one of the most common scripts that I've entered. We're still dealing in the point geometry, so let's just jump in and do that. Give me 1 second. We'll take this off to preview off, and we'll just start with a script in Python. So you want to go up to your math tool, grab your Python node, and get started. And we'll do it the same as we've always done from scratch. I'm going to keep these videos to hopefully under 8 minutes. So it's a very simple script, but it's one worth not memorizing, but understanding what's happening. And I'm going to try and describe it physically for sculptors and people and designers. Import, that's hard to describe physically, Rhino script syntax using autocomplete as RS. You'll be using that and the functions and all the methods within that. You're going to create a points list by setting up an array empty. You'll leave a couple of spaces, and you'll do the for iteration, which is just basically a nested iteration. Now, what I want you to think about is a pegboard, and you're going to go for I in range, whatever you want, and let's call it, and that would be in one direction, or just a number. Think of that going across the x-axis. Use the colon. You're then going to go for each one of those points across up for j in range, let's say m. So it can be a different set, colon n. And you're going to create a point that's equal to Rhino script add point. It will come up as autocomplete, and I just said add patch, add point. And let's bring in I and j. And just for interesting sake, let's bring in I times j. Now, normally you wouldn't do that. Well, let's leave it simple at 0, so keep things flat to start. I always get too excited. Then you're going to append your points array by adding each of those points as they're generated, as the nested loop goes I, j, I, all the way through, like I, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but running up, let's say, in the y-axis to whatever count you put on the j direction, which will be m. So all we have to do then is come out of the loop and get our outputs as point, and I'll recommend point out, underscore out is equal to points. And that should run, but what is the problem? Before we even try and run it, obviously we're going to need an m and an n. So n, and we're going to have to set that to an integer. And we're going to bring in an m variable and set that to an integer. We're going to want to set those as a slider, so let's just do 23, and that's a lot. Let's copy that and go here and bring that in for the m. Let's bring down the count. So always take your counts and your numbers down when you're running and testing a script. And then your out is going to be points underscore out. That should work fine. The script should run. And like I said before, make it a habit earlier or later in your script. My kids are being wild, and I really can't apologize for it. It's just the nature of having 3 kids. And we will run the script and see if we got lucky. And it ran fine. And what you'll see is generated is, first of all, nothing in out because it worked. And you've got this amazing system of taking a look at all these points being generated, counting 0, 0, 0 to 0, 1, 0, 0, 2, 0, 0, 3, 0. It's going to go all the way up to 9, and then it's going to hit 10, and then it's going to jump over here and go 1, 0, 0, 1, 2, 1, 1, 0, 1, 2, 0, and it's going to go all the way up until it gets to this point, and it's going to go 2, 0, 0. Then it's going to go 3, 0, 0, 4, 0, 0, 5, 0, 0, and it's a counting system of generating a grid of points. Now, you can try and visualize what's happening there. If you can understand the data, if you can see it within the computational script, you can see it within the parametric model of working in the Grasshopper canvas, and then you see the magic of what's happening within the, and what I should do is take off my other nodes, not to confuse you, disable, and what you can see is you have a grid of points that you parametrically can control that's computationally programmed. Let me just grab this on a better level. And you can have control over it moving here and here. And what I want to show is a little bit of pre-trig and pre-math. What's nice with this form is if I wanted to grab it and do something jazzy in the z direction, I could go into here and let's introduce, this is just something to add to it for those that are understanding this formula. Let's go ahead and write I times j and multiply it by z, and let's make z a very small factor of 1.00 because we are going into a multiplier, and add a z component that will be labeled, declare it, and assign it a variable float. And now what I can do is see what's generated. A very interesting script as it climbs up, but I can also parametrically control that, pull it back down flat. So you have this control, and now if you start using tools that most people get excited about with the plugin Weaverbird, and let's just pull a mesh out of those points, you see you've got a nice controllable mesh that's actually got some nice flex and flow to it. Let's take a look at all angles of it. You'll see what you're actually dealing with, except it's incredibly small because I've got a bunch of scripts on this file. And yeah, very, very tiny. And you can see the little flexibility there. And then from the top, what's happening to the mesh. So you're actually able to play that, have a little bit of control over that. You can play off of this parametric control that way and this way. And it's a pretty fast-moving script. But what I want you to think about is, how do I get thinking of rays of points to inform meshes? And it couldn't hurt to actually go in and try a surface from points. But with the surface from point count, you're going to have to grab one of your M or N counts to make that work. So let's take off everything else, and there you go. You've got a very flexible, beautiful, not mesh, but beautiful NURBS surface, which is very nice. As I rotate it around, you'll see the power of really getting into having this flexible form. And let's just see what that ends up generating as a baked form. It should be pretty simple. We'll group it, and I'll hit OK, except I can't with my ugly face there. And there we go. You got a very nice surface that you've actually baked into Rhino. From computationally compiling, as opposed to parametrically, you're utilizing that, but not building it in CAD. And that's the power of this whole system. So let's go back out of it, jive up into this, turn that on to preview on, leave this, jump into, shaded's fine, and I should have my colored border back to take a look and disappear my script within it. And we will just continue with geometry to the point and beyond. Ghpython node at WICKERSON Studios. That one's under 8 minutes. Thanks for watching.